Good afternoon, everyone. Thank you for joining today's session. I'm VJ LaRosa, the Chief Information Security Officer for Cisco's Network Platform Organization. And I'm here today to talk about something that keeps many of us up at night. How do we embrace AI innovation without becoming the next headline breach? Over the next 30 minutes, I'm going to share what we've learned on the front lines about building AI-first organizations that can move fast and stay secure. This isn't theoretical. These are battle-tested strategies from real deployments. So let's kick this off by framing the challenges that we're all facing today. At Cisco, I have the privilege of leading cybersecurity as the CISO for our network platform organization, which is the control plane to manage much of how the digital world is connected. My mission isn't just to secure what exists today, but it's to build the foundation of trust for the AI-powered systems we're rapidly leading the industry developing and moving towards. As we embed AI deeper into our networking and cloud infrastructure, our responsibility is to ensure that intelligence doesn't come at the expense of integrity, privacy, or control, because trust doesn't build itself. We engineer it. In my role, we're leading secure AI transformation at scale by weaving AI into the fabric of our global infrastructure, using it to anticipate, not just react to threats. That means making AI part of how we defend systems, how we verify identities, and how we continuously validate the trustworthiness of our platforms. It's about moving from after-the-fact security to real-time assurance. My team is focused on engineering trust directly into AI systems. We're creating secure by design frameworks that combine AI telemetry, identity assurance, and compliance automation. The goal is to make detection, prevention, and remediation not only faster, but autonomous. We want AI models that understand context, that can prove their decisions, and that can adapt responsibly without human delay. Ultimately, we're innovating at the intersection of security and intelligence, building AI-driven defense models that transform massive amounts of security data into decision engines that act in milliseconds. That's how we scale trust, not by adding more humans to monitor, but by teaching systems to defend themselves intelligently. Because the future of cybersecurity isn't about control. It's about confidence at machine speed. Here's the paradox we're living in right now. AI adoption is growing 3 times faster than cloud adoption did at its peak. Think about that for a second. Cloud took nearly a decade to reach mainstream adoption. AI is doing it in 3 years. The average enterprise isn't just running one AI pilot anymore. They're running 5 to 10 simultaneous AI initiatives. I've seen companies with teams in marketing running ChatGPT integrations, data science teams deploying custom models, and developers embedding AI APIs, often without central coordination. Meanwhile, our security frameworks are still catching up. Organizations are trying to apply perimeter security to systems that don't have perimeters. We're trying to use compliance frameworks written before transformers existed. The gap between innovation, speed, and security maturity isn't just growing, it's accelerating. I hear from friends across the industry regularly about them discovering data science teams or other groups in their companies training models on customer data without any security reviews. Not because they were reckless, they just didn't know they needed to. That's the world we're operating in. So here's what I tell people all the time. We can't slow down AI. That ship has sailed. What we can do is speed up security. And that's what this talk is about. Before we talk solutions, we need to understand why our existing security playbooks don't work for AI. There are 4 fundamental reasons. First, data gravity. AI models need massive data sets. We're talking terabytes, sometimes petabytes. This data moves constantly between storage, training clusters, and inference endpoints. Traditional perimeter security assumes data sits in one place behind a firewall. That assumption is dead. Second, model opacity. When you deploy a web application, you can inspect every line of code. With AI models, especially large language models or neural networks, you've got billions of parameters in a black box. How do you detect anomalies when you can't see what normal looks like? Third, supply chain attacks. Raise your hand if you've used a pre-trained model from Hugging Face or downloaded a Python library for machine learning. I'm sure there's a lot of raised hands behind those cameras, but here's the question. Do you know what's actually in those models? Have you audited every dependency? The AI supply chain is the Wild West right now. We've seen backdoors in popular repositories that stayed undetected for months. And fourth, the speed problem. Traditional security reviews take weeks. AI teams want to deploy models in days or hours. If your security process adds 3 weeks of latency, here's what happens. Teams go around you. They find workarounds. Security becomes the obstacle to avoid, not the partner to engage. These aren't hypothetical problems. These are real problems we're seeing in production environments in every company right now. So what do we do about it? What we need is a fundamentally different approach. Not AI security as an afterthought, but secure by design as a foundation. Today, I'm going to walk you through a framework built on 4 pillars we can rely on. Number 1, data security, protecting the fuel that powers AI. Number 2, model integrity, ensuring your models do what you think they do. Number 3, pipeline governance, securing the entire ML lifecycle. And last, runtime protection, defending models in production. We're going to spend the next 15 minutes or so diving deep into each pillar with specific actionable strategies that you can implement. These aren't aspirational. We've deployed every one of these at scale, and so can you. So let's start with the foundation, data security. If AI models are engines, data is the fuel. And right now, most organizations are storing high-octane fuel in paper bags. We need to do better. The first principle, classify data before it enters your AI pipeline, not after. We must tag PII, sensitive customer data, regulated content, all of this at the ingestion point. This means when data scientists query a training data set, they immediately see this contains customer financial data, special handling required. No surprises downstream. Second, federated learning. This is a game changer for industries like healthcare or finance. Instead of centralizing sensitive data to train models, you train locally on distributed data sets and only share model updates. The raw data never leaves its secure environment. I have a long history fighting financial fraud and building platforms in this space, and I still spend a lot of time speaking with customers and peers in this world. And what I've seen is that federated learning in financial services, for example, has really allowed institutions to collaborate on fraud detection without moving raw data, dramatically reducing the risk of large-scale data exposure and increasing their model's efficacy. This is also proving effective in my world today at Cisco. The third strategy, synthetic data generation. For certain use cases like testing, development, or training, you don't need real data. You need realistic data. Synthetic data generators can create statistically similar data sets with zero privacy risk. We use this extensively for pre-production model testing. And finally, data lineage tracking. Every byte that goes into a model needs a documented chain of custody. Where did this data come from? When was it collected? Who approved its use? What transformations were applied? If you can't answer these questions, you can't defend your model in an audit or a breach investigation. That's the data foundation. Now let's talk about protecting the models themselves. Let's talk about the second pillar in our Secure by Design framework, model integrity. Here's a sobering statistic. Carrier Management recently published a survey of 50 IT security and data science leaders, and the results showed 98% of the responders said some of their AI models were critical to business success. Yet 77% reported at least one AI-related breach in the past year. This is just one example showing how the gap between rapidly expanding AI deployments and mature protections is indicating we have an industry-wide problem with a heightened risk landscape for enterprises, while underscoring the need for proactive AI model security controls. So our first line of defense, treat models like code. Every model should get cryptographically signed by the data scientists who trained it. Every version is tracked. Every deployment is verified. If someone tries to swap out a production model with a compromised version, the signature won't match and the deployment should fail automatically. Second, you must red team your models before they go live. Adversarial testing means actively trying to break your own models. Prompt injection attacks where malicious inputs make LLMs ignore their instructions. Data poisoning where manipulated training data creates backdoors. Model inversion where attackers extract sensitive training data through clever queries. Doing this real time is critical, so using automation to help perform AI-based red teaming against AI models is critical to keep up with the pace. Most people that I speak with tell me that the first time they did any comprehensive adversarial testing on their AI models, like customer chatbots that their organizations have been developing, they broke them in about 15 minutes. AI pen testers can typically get these systems to leak internal documentation with the right prompt structure easily when security has not been at the table helping to design and protect their work. It's embarrassing, but it's far better to find it in testing than in production. Third is supply chain validation. Before you import any external model or library, ask 3 questions. Who created it? How was it trained? And what dependencies does it have? You need to maintain an approved model registry. If it's not on the list, it doesn't touch production data, period. And finally, role-based access control for models. Not everyone needs to deploy models. Not everyone needs to modify them. Not everyone needs to query them with arbitrary inputs. Least privileges applies to AI just like it applies to databases and servers. Model integrity protects what you build. But how do you govern how you build it? That's where pipeline governance comes in. AI isn't a one-time deployment. It's a continuous pipeline. Data ingestion, feature engineering, model training, validation, deployment, monitoring, retraining. Security can't be a gate at the end. It needs to be woven into every stage. This is where ML Ops meets SecOps. You must embed security checks directly into the CI/CD pipeline for models. Before a model can progress from deployment to staging to production, it passes automated security gates. Does it meet our data classification requirements? Has it been adversarially tested? Is the training data lineage documented? If the answer to any of these is no, the pipeline stops. This is shift left for AI. Catch problems early when they're cheap and easy to fix. Our data shows that 90% of security issues we catch in automated pipeline checks would have become production incidents without these gates, and fixing them takes hours instead of weeks. Second, policy as code for compliance. GDPR, CCPA, HIPAA, SOC 2, these aren't suggestions. Encode compliance requirements as automated checks. If a model is trained on European customer data, it has to include data deletion capabilities for GDPR right to be forgotten requests. If it processes health data, encryption requirements have to be enforced automatically. Compliance isn't a manual checklist, it's code. Using open source tools like CodeGuard can help you ensure the processes along the way are done consistently and securely. Third, immutable audit trails. Every action in the ML lifecycle gets logged. Who trained the model? What data was used? When it was deployed? What changes were made? These logs must be write-only and cryptographically sealed. You can't retroactively cover your tracks. And here's the uncomfortable truth. Shadow AI is everywhere. Marketing teams running ChatGPT plugins, engineers embedding GitHub, Copilot, analysts using Claude for data analysis. These aren't sanctioned systems in a lot of cases, and they're processing company data. You need to use network monitoring and API analytics to discover these shadow AI systems, then work with the teams to bring them into governance rather than shut them down. Pipeline governance gets you to production safely, but production is where the real battle begins. Here's a reality that should concern all of us. The majority of AI breaches are being detected after deployment, not during development. The majority of attacks happen when models are live and facing real users. The truth is, once we're live, it's our last line of defense. Continuous monitoring for anomalies. You need to track inference patterns. What inputs are coming in, what outputs are going out, how frequently users are querying models. When you see unusual patterns, like someone querying a customer service bot 10,000 times in an hour, they're most likely testing for vulnerabilities, and you need to get alerted immediately. Second, rate limiting and throttling. This defends against both denial of service attacks and model extraction attempts. Attackers can steal model behaviors by making millions of queries and reverse engineering the outputs. Rate limiting prevents this. If you're a legitimate user, you'll never hit the limits. If you're an attacker, you need to be blocked. Third is output filtering and content safety. Large language models can generate toxic content, biased responses, or inadvertently leak sensitive information they learned during training. You need to run every model output through content filters before it reaches users. If a model tries to generate something harmful or private, ensure it gets blocked at the output layer. I recently was briefed on an incident where a customer-facing AI assistant started returning internal product codes in responses, information that wasn't public yet. That model had learned these codes from internal documentation in its training set. Output filtering caught it before customers saw it. The tools worked. That's why this layer is non-negotiable. And finally, AI-specific incident response playbooks. When you have a traditional security breach, you probably know what to do. Isolate systems, preserve evidence, notify stakeholders. But what do you do when a model is compromised? Do you roll back to a previous version? Do you retrain from scratch? Do you take it offline entirely? These are decisions that need to be pre-planned, not made in a crisis. Those are the four pillars. Now you might be thinking, this sounds great, but how do I actually implement this in my organization? Let's talk about a practical roadmap. So, giving you a lot of concepts, let's make this concrete. If you're starting this journey on Monday, here's what the first 90 days should look like. Month one is about knowing what you have. Inventory every AI asset in your organization, and I mean every asset, including shadow AI. Conduct risk assessments on your most critical models. Document your current policies and identify gaps. This phase is not glamorous, but it's essential. You can't secure what you don't know exists. Month two is about momentum. Implement quick wins that demonstrate value. Set up model access controls. This can be done in days, not months. Start classifying your training data. Deploy basic monitoring on production models. These aren't the complete solution, but they show progress and build organizational support. Month three is about scaling. Integration of security checks into your ML ops pipelines. Automating compliance validations. Launching organization-wide training so every data scientist, ML engineer, and product manager understands their security responsibilities. By day 90, you should have the foundation in place to scale security. Now, I'll be honest with you. 90 days gets you the foundation, not perfection. This is a journey, not a destination. But if you execute these 90 days well, you'll be ahead of 80% of the organizations out there, and you'll have built the muscle to continue improving. Next, I want to share some lessons we've learned the hard way so you don't have to. Over the past few years, implementing this framework, we've learned some lessons that don't show up in any textbook. Here's the four that I think matter the most. First, security needs to be an enabler, not a blocker. This requires a mindset shift. We embedded security engineers directly into AI product teams, not to review their work after the fact, but to collaborate from day one. And you know what happened? Development cycles got faster. Why? Because security engineers help teams avoid dead ends, navigate compliance early, and build more robust systems from the start. Security should accelerate innovation, not slow it down. Second, automate everything. Manual security reviews don't scale at AI velocity, period. If you're still doing manual code reviews for model deployments, you're already behind. Policy as code isn't optional. It's the only way to keep pace. We've automated 90% of our security checks. The 10% we keep manual are high risk, high value decisions that genuinely need human judgment. Third, assume breach. This is straight from zero trust principles. Design your systems assuming attackers will get in. What does that mean practically? Segment your AI infrastructure. Use least privilege access everywhere. Build in rapid recovery capabilities. Can you roll back in a compromised model in minutes, not hours? Can you retrain from clean data sources quickly? Personally, I believe resilience matters more than prevention. And fourth, culture eats strategy for breakfast. You can have the best security framework in the world, but if your data scientists see it as bureaucracy to avoid, you've already lost. We invest heavily in training. Every AI practitioner, data scientist, ML engineer, product manager goes through security fundamentals training. Not a boring compliance video, but practical hands-on training on real scenarios. Because security isn't the CISO's job alone. It's everyone's job. That last one is probably the most important. Technology is easy compared to cultural change, but if you get cultural change right, everything else follows. Now, how do you know if this is actually working? You need metrics. You can't improve what you don't measure. So here's the 4 metrics I believe need to be tracked religiously to know whether your secure by design approach is working. First is mean time to secure deployment. How long does it take to go from model trained to model in production? Our target is under 48 hours. If you're taking weeks, your security process is too heavy. If you're taking hours, you might be skipping critical checks. 48 hours, I believe, is about the sweet spot we found between speed and thoroughness. Second, shadow AI discovery rate. What percentage of unsanctioned AI usage are you detecting? Aim for 95% of your organization or higher. This tells you whether your monitoring is comprehensive or whether teams are successfully working around you. If your discovery rate is low, either you have amazing compliance or terrible visibility. Probably the latter. Third model, vulnerability remediation time. When you discover a critical security issue in a deployed model, how fast can you patch it? Our target is less than 1 day for critical, less than 3 days for high, less than 7 days for medium, and less than 14 days for low vulnerabilities. This requires automation, pre-approved fixes, and clear decision rights. Anything longer than this, you're leaving yourself open from an attack perspective. And fourth, security coverage. What percentage of your AI workloads have runtime monitoring, access controls, and audit trails? The only acceptable answer is 100%. Any gaps are risk. We track this weekly and our executive team reviews it monthly. Here's why these metrics matter to the C-suite. They prove security isn't slowing down business. Fast deployment times show agility. High discovery rates show governance. Quick remediation shows maturity. Full coverage shows risk reduction. These metrics make security measurable and defensible. Those metrics tell you how you're doing today, but what about tomorrow? Let's talk a little bit about what we see coming on the threat horizon. The threat landscape for AI is evolving faster than any attack surface we've seen. These are 4 emerging threats that should be on your radar to address in the next few months. First is automated prompt injection attacks. We're already seeing botnets specifically designed to test LLM vulnerabilities at scale. These aren't manual attacks, they're algorithmic, testing thousands of prompt variations to find exploits. Defense requires equally automated detection and filtering. The second, model inversion attacks. Attackers are getting sophisticated at extracting training data from deployed models. If your model was trained on customer data, clever queries can potentially reconstruct that data. This is especially concerning for models trained on sensitive information. Differential privacy during training and strict output filtering are your defenses here. Third is supply chain poisoning. We're seeing compromised models uploaded to popular repositories, malicious dependencies in ML libraries, and backdoored pre-trained models. The open source AI ecosystem is both a blessing and a curse. Trust but verify, but actually probably just verify. And fourth, deepfake enabled social engineering. AI-powered voice cloning and video synthesis are making phishing attacks dramatically more effective. I've seen recent cases where attackers cloned a CEO's voice to authorize fraudulent wire transfers. Social engineering isn't just an email problem. Your employees need training to recognize and verify unusual requests, even when they look and sound authentic. But here's the meta threat. All of these evolve daily. The defenses that work today might be obsolete in 6 months. Your security posture can't be static. It needs to be adaptive, continuously learning, continuously improving, which is ironic because that's exactly what we're asking AI to do. So let's bring this all together. You've got the framework, you've got the roadmap, you've got the metrics, you've seen the threats. What's your next step? Here's a 6-step blueprint to take with you. It's your action plan. 1. Inventory and classify all AI assets and data flows. Know what you have. 2. Implement the 4 pillars. Data security, model integrity, pipeline governance, runtime protection, in that order. 3. Automate security controls in your ML ops workflows. Manual doesn't scale. 4. Establish continuous monitoring and threat intelligence. See attacks before they succeed. 5. Build a security-aware AI culture through training. Make it everyone's job. 6. Measure, iterate, and adapt to emerging threats. I said this before, this is a journey, not a destination. So take a screenshot of this slide right now. This is your Monday morning checklist. Last, let me leave you with one final thought. I want to leave you with this quote, which sums up everything we've discussed today. The organizations that win with AI won't be the fastest. They'll be the ones who innovate securely, sustainably, and at scale. So 3 things to remember. First, start your secure by design journey today. Not next quarter, not after the next incident, today. Second, security and innovation are not trade-offs, they're multipliers. Done right, security makes innovation faster and more sustainable. And third, build AI systems that your customers can trust. Trust is your competitive advantage in the AI era. We're at the beginning of the AI revolution, not the end. The organizations that figure out how to innovate without fear, that balance speed with security, autonomy with governance, experimentation with responsibility, those organizations will lead the next decade. I'm excited about the future of AI, and I hope you are too. And I hope this framework helps you build that future safely and securely from an AI perspective. Thank you for your time. I hope everyone enjoyed this presentation.